Today I want to review with you the stock naming system for ionic compounds. As we know already, all ionic compounds contain a metal and a non-metal. However, some of them, such as the transition metals, are metals that we don't know the charge of. Those are ones that we need to add information to the reader to help us understand which ion is going to be. So let's look at what we're talking about. These transition metals are the ones that are under the staircase and in the D block on the periodic table. These metals have the addition of that extra D sublevel, which allows them to pull valence electrons from not only their S and P, but also their D. So they can use, sometimes they can pull more if they need to. And there's really no way to tell from the periodic table which ion that will be. So let's look at iron, for example. Iron on our periodic table is number 26. Iron can be a 2+, a 3+, or even a 6+. And from the periodic table, we have no way to tell. So again, scientists have decided to use Roman numerals in the name to identify the positive charge of the metal. Just to review the Roman numerals, we have 1, 2, 3, 4, 5, and 6. Those are probably the most common ones you're going to find. These Roman numerals are used after the name of the metal to indicate the positive charge, and they're written in parentheses after the metal name. So before, we had the 2+ iron ion, so that would be written as iron 2. This again tells us that it's a 2+. The iron 3 would simply be written as iron 1, 2, 3. That tells us it's a 3+. And the last one is the 6+. It is iron, that would be one after the V. And that's our 6+, all right? So we don't actually need to write these, that's just telling us what it is. There are a few places or a few times where we don't want to use Roman numerals. The first thing is in the formula, we don't ever want to use this. We don't ever want to put the Roman numeral in the formula. It's only for the name. Second one would be for any metal with a constant charge. These are things like group 1 is always a +1. Group 2 is always a +2. Aluminum is always a +3. Now those are in a representative column, so it's unlikely that you would confuse those with variable metals, but these transition metals, zinc and cadmium, silver, those are exceptions to our rules because they're in the transition metals, but for whatever reason they always form a consistent charge. So zinc and cadmium are always going to be +2, and silver will always be +2. So it's helpful for you to memorize these because they will come up a lot and you want to be able to identify those charges. Okay, now that we know what the stock naming system is, we want to make sure that we know how to use it. First thing, how to write the formula from the name. So when we're given the name of an ionic compound, it's just like we did before. We're going to write the symbol and the charge. Previously, we found the symbol from the periodic table, like we do with oxygen. With iron now, since it's a transition metal, we need to use this for that charge. That's going to indicate it's a +3. So the Roman numerals are always a positive charge because they're metals. And then from there, we're going to crisscross just like we did before. And that's going to give us that electrically neutral compound. So we end up with Fe2O3. All right. Now notice this, the Roman numerals, is not the same as the subscript. So the Roman numeral does not equal the subscript. You get the subscript from the crisscross. So be careful with that. The second part of this is going to be writing the name from the formula. This is a little bit more tricky. What it's going to take is reversing the crisscross to determine the original charge of each ion. So if we started with this 3, bring that up there, and that would have originally been a 3- because the second element is always the anion. On the other side, you have the 2. That now becomes the plus. So it becomes Ti would have started with the 2+, N would have started with the 3 minus. So writing the name now, we use this for our Roman numeral. So the answer is titanium 2 nitride. 99% of the time, that's going to work. However, the anion is going to tell us if it's going to be an issue. Sometimes the original formula was reduced. And if that's the case, then that anion is not going to be correct, and we need to adjust our charges accordingly. So let's do an example. Let's do MnO2. Let's start by reversing our crisscross, and that gives us a 1 minus on the oxygen. That's not okay, because we know that oxygen usually is a charge of 2 minus. So that's telling us we're off by a factor of 2, because x times minus 1 should equal minus 2, which this is our actual charge. So make that a 2, so that would have been Mn2O4. All right, so now we can go ahead and reverse that crisscross. This was our original. Let's go ahead and reverse it. Now that gives us a 2 minus, much better. 4 plus. So we have Mn4 plus O2 minus. This becomes our Roman numeral. So it's manganese 4 oxide. This reducing thing doesn't happen very often, but when it does, you need to know how to handle it, because your teacher's probably going to want to test you on it.